Hello and welcome back to a new video here on the Ludwig Fusel channel. In today's video we're going to continue on with our 3D object generation through C++ and Lua. Now in the last video we have implemented MTL files, previously we have implemented OBJ files, and basically what we got is that we can, inside of 3D viewer, we can... Hopefully open recent now works. Of course it does not work. However, we can open up our cube now, and as you can see, we now have a nicely colored and shiny cube inside our 3D viewer. So this is basically what we can do currently. What I now want to do is I want to now continue on and make the export a bit easier, and then I want to start writing a bit of code that allows us to kind of like generate primitives from Lua. I'm not sure how I want to do it yet, but we're gonna find a certain way. Probably we're gonna make it quite complex, and later on kind of like streamline it into the like OBJ structure. So in general, like the OBJ is quite plain on how it works. I kind of like want to make it a bit different first to then kind of like unify objects. But maybe I'm gonna do it differently. We're gonna see. Well, let's first start with creating the obj export.h in here, because I want to write a obj export. So this is just a very simple class that's gonna streamline a bit of the creation. So Lua, this is the namespace, and the class is the obj export. Alright, so now we have it like that. And let's write a public and a private interface. And let's do it like this, and then let's start by including what we need. So Lua mtl lib obj mtl file and obj file. So internal, what I want to have is I want to have a obj file, and I'm going to call this one my obj, and I want to have an mtl file, which is my mtl. And what I want to do is I want to be able to kind of like create this export and then save it. So what this export shall do, it shall have two functions. So the first one is going to be called void append object, which allows us to append an object to the obj file. So obj object is what we want to have. We want to move that object and call this one object. All right, so let's create a file and let's write the code for that, append object. And when I call append object, what I want to do is that to my obj, I want to go to my objects and then want to push back the newly created objects with std move. I don't know why I defaulted to move backward, but I don't know, like this is how I wanted to do it. And yeah, what I now want to have is I now want to also, of course, support materials. So I want to actually support multiple operations on materials. First, I want to have the append material function, which is an mtl material. So like this. And let's say we add some comments. Appends an object to the export. And then we have the object in here, which is the object to be appended to the output. Alright, so now what I want to have is I want to have a description here. So appends material to the output. And then I kind of like want to have a function in here. Or do I want to make it different? I'm not sure how I want to do it with materials, because I think... How do I want to implement these? Do I want to implement this a bit more fancier? Maybe I want to... No, I don't want to implement it fancier, because this interface doesn't need to be fancy. Later on, we need to have it a bit more fancier. So, material. This is basically the basics operation that this class will do, but it shall also, of course, support more things. So let's first implement this one. Materials.pushback material with std move like this. And what I now want to have is I want to have a void save, and the save function takes a string view Or let's actually take a file system. Let's include a, no, I don't, oh, let's include it. Let's include a file system, and I want to call that one const std file system path base path. Or let's call it mtl or obj. Now let's call it base file path. So it's a base file path. However, this is a special one. Of course, it needs to be a reference. And this shall also maybe return a bool if it was successfully. Maybe like that. This makes it a bit easier to use. So first of all, save is writes the changes, writes the obj and mtl file to disk. Now base file path is basically the file path to file without .obj or .mtl extension. So basically I'm allowed to write to every file that I wanted. It's always going to create a matching file. True on success. This is what it does. Now I want to implement the logic. Now out of these paths I need to make multiple paths. I want to have the obj path, which is going to be equal to base file path, and then the obj path replace extension is going to be replaced to .obj, and then auto mdl path base file path and mtl, not mdl, mtl, the mtl path replace extension to .mtl. Okay, so now I need to determine if I need to have the material. So if my mtl materials empty, so if I have materials, so we need to invert it. So if I have some materials, I need to reference them. So in my obj file, mtl file name, the mtl file name need to be provided. So we're gonna take the file name here. So we take the file name and an mtl so that we have an extension. So now we have referenced the mtl file. Then we need to save the mtl file. So auto mtl file is going to be equal to std off stream. Now let's do it like this. Off stream mtl file. And we're going to open from the mtl path. std ios out, std ios, how does this trunk? So I want to truncate existing files. So this is the mtl file. Do I not have fstream in here? No. Fstream, so that we have access to these, so that we can open it up. So if not mtl file, so if there was something wrong, I want to return false, because now something has gone wrong. But I want to, of course, check the is open. I think it would be possible just like that, but I tend to also keep the is open. Now what we can now do is to the mtl file, I am gonna spill out my mtl, and this is fine. Now I want to go for the object file, offstream obj file. It's obj path, std ios out, std ios trunk like this. If obj file is open, if this is not the case, we return false. Otherwise we say obj file goes the obj object, and then we return true. So now we have a bit of boilerplate code around my export, which we of course now inside of the main also want to use. So instead of including these, we are going to include the obj export, and instead of these and having the obj file in here, I want to basically have a Luma 3D obj object that returns, and instead of appending it, we are going to return the cube like this. Similar works for the material or materials, so it's multiple. MTL file. Okay, no. We could also, okay, let's do it differently. We can directly reference the export. So let's reference the export here. So Lua MD obj export, reference export. Yeah, let's call it out. Let's call it out, quite simple out. And then we're gonna say out append object cube std move cube to return it to there. And we do it differently here. Lua obj export out. And then I'm gonna say out dot append material std move material like this. And then this should work. Instead of all of this cumbersome code here, we just gonna have like one obj export out. And then we're gonna create the cube and we're gonna create the materials. We could do it the other way around, kind of makes more sense, but it really doesn't care. And then I want to save to ./cube. So this is kind of like where I want to save it, and then it should automatically apply the correct extensions. Let's go into Visual Studio Code and let's delete the existing files so that we can verify that this works. So now the folder's empty. Let's see if it compiles even, but it should not have any issues during compiling, definitely. So let's see. Okay, so it runs. And it also creates these, but however, you can see that the cube itself has been modified. Because it's, if I would go into the changes, you can see that it's like cube.mtl.mtl. So why is it cube.mtl.mtl? Was the file name already including the extension? Probably. You can see that it was taking the file name, as we can see the file name somehow it contains the extension. So we can fix it by removing it. And if I take a look here now, it should not have any differences in Git. So we now have the exact output, but in a bit more like streamlined way. And now what I want to do is I want to implement this into a Lua VM. So basically what I am gonna do is I am gonna create something called, I want to call it Lua VM because it's kind of like, let's call this Lua Draw. Let's call it Lua Draw because we are kind of like drawing. And then I want to call this one LD state. So this is kind of like the Lua Draw state. Lua MDL, and then we're gonna have a class LD state. This is the Lua state that we are using for drawing. Now this is not gonna contain anything about the actual Lua code or the actual Lua bindings. This is kind of like the state, but maybe we want to have the bind functions in here as well. Yeah, why not? Let's actually have the bindings in there as well. Now, in general, I think Sol 2 does handle instance management. Sol.hpp. So basically what this function shall have, it shall have a static. I don't know, how did they do classes on Sol? I haven't opened up Firefox at all today. That's great. So let's go into the docs and let's have a look. Tutorial, quick and dirty. Set and get. I want to have like user types, user data, user types, but I think I'm not gonna have extensive docs here because somehow this does not work how I want it. Because I don't want to have, I do want to have like functions, but a function to a class. There was something. I hate this one. It was, I think, in the tutorial. There was somewhere some code that went into a function. some function struct, some class. So how is it referencing the class? Lua set. Later into Lua. So it's kind of like adding member function, some class. Now, I don't think that we want to have it like this. So we should have somehow a way to kind of like statically bind to this. Now, how do I want to implement this? I kind of tend to do it with singletons, or do I just make the LD state a namespace and have everything in a namespace and then kind of like link to a global struct? Maybe this is the better way. LD state is now going to be a namespace, which does kind of look odd. And then I'm going to have a data struct in here that's kind of like exposed, and this data struct is going to have an instance. So I want to have an inline data reference get data, and this is going to return let's first I need an instance, static data instance. We could also just call it data, and then we can return data. So this is now kind of like exposing data to the public, and now in between we want to have the LD state modifications. So this is now basically, this is a very big class. LD state end. Let's maybe call this one start, LD state start, and LD state end. Actually, we think we can even put the data struct down here. However, I do want to have it kind of like accessible, so I always want to have it put at the top of the code. So, first of all, I want to have a std string and call this one out. Or let's call this one path. Output path, or let's call this just output. Let's try to keep this as close to the Lua syntax that we have. Or actually, I don't think that I need this at all. But let's start with some very basic syntax that we would have in Lua. So in Lua, I would have a save call. So what I would have is a function called save, and the save function would take a string, a std string, output path. This is kind of like a function that we would have in Lua. Now, as you can see, I'm kind of like following a new convention here. You can see that normally I was like this certain case that I used, and now I'm using a different one. This is because I kind of like want to mimic the Lua syntax, and in Lua we're going to do it like this. Now for the bindings, we of course also need to implement this. So void bind is something, and this is going to contain a sol state reference Lua state. This is kind of like now the function that we have. Let's maybe add some doxygen comments. Retrieves the instance of the state data, and then down here we return static instance as a reference. And this is binding the public interface to Lua. Lua state to bind on. So this is basically now how this is going to work. We're going to have a lot of functions in between, and these in between functions are basically bound to Lua, and as they are kind of like non-class, we can basically call them, and this is going to be like a state, like kind of a state machine. However, it's not a state machine, but it's somehow a state machine without like really being a machine. It's basically a just a virtual state in the application, and as soon as you're kind of like say clicking save or calling the save method, the state is converted to an OBJ file. This is the idea that I try to follow here. Now the bind function is quite simple. Lua state add function or set function. This is how it would be go. Then we have the key and the argument. Now we had a bit of a problems with defining these, so I want to use the save T. I kind of like want to now define these types actually. And this is going to be a void pointer std string. And actually we can do a const std string. And maybe I do want to kind of like keep these together. So it's always going to be a pack of 2. And what I can do is kind of like I can convert this function now like this, and then they should work, which makes the handling for me a bit easier. Now, how is save going to work? Now, of course, save needs some stuff to do. So basically, the Lua, the LD state, where do I want to include all my stuff? I think this is a Lua interface. This is kind of like a minimal one. So I kind of like want to have my include pollution at the CPP file. So I want to have my includes here actually. So let's include my UI, but I think it's going to be, no, the MTL, I think the export is included here because the export is not part of the public API. So let's make, this is probably only the export is the only one that's going to be here. So obj export, and basically, or data, let's call it like this. And then down here, we're going to say data.save, and we're going to save at the output path. Currently, this is completely empty, but for now, this is fine. So save is kind of like the last function that we're going to call. What I now want to have is I have a bit of kind of like a bit of a state manipulation. So what I want to be able to is I kind of like want to be able to start an object. So what we're going to have is we're going to have an std string current object. That's kind of like selected, and I want to have a current subgroup. So we're going to have an object and we're going to have a subgroup. Or let's not call the subgroup, let's actually call this group. So what I want to then have is I want to have a object t function, which is going to have a void pointer and also contains a std string. So this is kind of like how I'm defining an object. So then what I want to have is the function that goes with these. So const std string name. So this is now defining the object. Now the same thing shall also go for the group. We can kind of like define an object, and then we can define a group. Yeah, we might change the interface later on, because I kind of like doubt that this is a good idea to have these current ones as strings and not kind of like store a dynamic selection index, which I think would be more fitting to kind of like have a dynamic pointing selector. But for now, of course, it's trying to always put it wherever it likes it. Right? This is something that I don't like at Visual Assist, that it tends to put the data wherever it wants and not where I want it. Now, in the general idea, what I want to do is like get data, and then I say like current object equals name. This is kind of like what I want to somehow do, maybe like this, because it's a struct. This is kind of like what I want to mimic. But maybe it's not even too bad to have a flow like this. Let's try it out. Current group. This is somehow also preventing some edge cases. So kind of like, as you can see now, the interface is actually quite simple currently. You can see we are just altering a state. Object t, group t, group. And now basically this is a bare minimum interface. What I want to do quickly is now, let's actually keep this as is for now, and let's just get this up and running. Because as you can see, currently I'm like binding a bit of boilerplate code. Lua draw is here. We should maybe move the SPD log binding somewhere else. So yeah, let's add a Lua util folder, or let's call it Lua lib. So it's kind of like the library for Lua, and inside Lua lib we have LL logging, which is looking quite interesting. It's a CPP file. Come on, like this. Okay, LL logging, logging.h, namespace is Lua, and then there is going to be the It's not going to be a class, it's just wanna be a function void bind ll logging, or ll bind logging is how I want to call this, Lua lib bind logging. So hashtag include spdlog, spdlog.h, and inside of here, of course, we need to have sol as well, sol in here, and then we're gonna have a sol state, Lua state, will bind the info warn and error logging functions. State to register on. So this is kind of like how I want to implement that, and then I'm gonna go in here and move the code down there, and then I want to do the binding here. So set function is what I want to use, and now in here I do kind of like want to make this now as a lambda, because it's going to make things a bit easier on this side. And it's going to take a const std string reference message, and this is then going to be like the info function, and it's spdlog info msg. I don't think this is really necessary, right? It's not like log4j that you can inject something. I'm not sure, since log4j had some issues. I'd rather go for it like that. So info warn and error, warn and error. All right, so now these are kind of like bound in here, which means that I can forget about these in here. The Lua open library is still required. This is now no longer required. I could kind of like move these into something. Let's actually add something interesting. Let's add something called ld demo, Lua draw demo. And inside of this Lua draw demo, what I want to implement is I want to kind of like implement kind of like this demo cube that I currently have in the main, which is kind of like a good idea. So we can reuse the code that ChatGPT has generated here. We do not no longer need these. We need the material names, however. But let's go into ld demo and paste them in here. ld demo create cube and ld demo materials. This code is gonna go somewhere else, and currently you can see it directly goes to the exporter, so I think we're going to be fine to leave it for now in the demo, or maybe not, but yeah, we need to later on move this to a different kind of like way of doing it. But for now, I just want to have this demo code in here. So let's include the lib, let's include obj, let's include the obj export in here, which should make these all work. The only thing that doesn't work now is the materials. They need to be now taken over as well. These are here. This is no longer needed. This is also no longer needed. The SPD log is also currently not used, so I'm going to remove it. These ones as well. So sol is used, and what I also want to use is I want to include my new kind of like state machine, or I want to include multiple stuff. I want to first include my Lua lib, and then I want to include my Lua draw state. And basically what I want to do is, after opening the libraries, I want to say Lua, actually not Lua, I want to say Lua build3d ll bind logging, so that we are binding our logging. And then what I want to say is the ld state, and I want to bind the ld state so that we are now able to operate with it. And then we can just run our script.lua, and it should have access to all the functions in the ld state. Now the ld demo is missing the global array, so let's make this different. So let's make this a inline const expression constr pointer, and let's call them ld demo material names. So now we have a bit of a better explanation on what these are. And then let's maybe inline them a bit so that they are a bit nicer displayed. So yeah, kind of like material names for the demo. And then I can, everywhere where we have these missing, I can replace these for the proper one. And now I have a proper linking to them. Okay. Creates a normal group function generated by ChatGPT. Okay, so output is the export output, which we're gonna change later. And I do just want to steal this. Create a... It's a normal group. What? Creates a normal cube. Creates textures for the cube. So now we have a bit of an information. Let's now create a matching source file, and let's go in here and let's say move implementation to source file. And let's do it here as well. Move implementation to source file. So now we have them in here. Now the only thing that I need to do for the Lua state, I now actually need to move something in here that I try to keep separated, but I think this is it really doesn't matter. I can just include this in here. Let's include it here. It's not too big of a deal to include it in here. We can then spare it here. This one include is not going to hurt us. Obj export. So now we have the export definitions in here. And now instead of taking a look, at these ones down here, basically what I'm just going to say is I'm going to say get data.export.save. So now we can kind of like save the export. And what I now want to implement is I want to have implement the demo cube. So object group. And since this demo cube is kind of like something completely... something completely unique. Let's maybe put it to the top because it's like a demo. Demo underscore cube t is the function that's going to be called. So that's just going to be a completely void function. Void demo cube, and this function just looks like this. And the demo cube function is going to kind of like reset the whole object. This is something that we need to implement because it's not working out of the box. So let's call the get data current group. So this is cleared. And this is cleared. And then what I also want to do is in the export, I want to clear the export. The export can't be cleared currently. So let's implement this feature. Let's implement a void clear. Clears all data from the export. Let's implement this in here. So in general, it's quite simple. The obj file has a comment. We don't want to alter this. The material will be cleared. And then I will go into the objects and clear them. This is quite simple. The MTL has just materials that we need to clear, and now it's cleared. Now in the state, what I can now do is I'm gonna get data export.clear. So now we have cleared everything, and now what I want to have is the LD demo create materials. We're just gonna get data.export. So now we are kind of like generating the data in here. No, I didn't want it to change this. I wanted the LD demo material names. No, how the function's called? LD demo create group. Why didn't you suggested me that? Okay, so now I basically create a group and create the material. So I'm basically taking my whole data and I'm going to clear it, and then I'm going to enter it. I need to clear it because it's not in the new interface that we're implementing. At some point I want to have the cube as a demo that you can create always, but currently we need to have it separated. Demo cube. Did I call it demo cube? Yeah, demo cube. Demo cube t. And then I want to call this one demo cube in here. So now the demo cube is bound. This should build without any issues, hopefully. And if there are, they should be minimal and easy fixable. And now, as you can see, oh, we're gonna get some, what? Unresolved. Ah, yeah, because I pressed the complete build, but this is not a big deal. So as you can see, if I run it, nothing happens. We're just gonna get a error descriptor is empty. I want to quickly delete this data from disk again, so that we can see that we are going to start from scratch. Now, if I run this code, you're going to see that I will not get any data. However, you can see that I'm going to get a one, the script is empty, and I want to replace this with info, and I want to write generating a demo cube. So I want to kind of like say that we are doing a demo cube. Demo cube is what I then want to call. So this is what I do, is I do a demo cube, and then I'm going to save add demo underscore cube. This is now my script that I want to run. I don't know. Can I do it like this without calling it? I think this doesn't work, right? It does? Does it? I'm not sure. I didn't get a cube, so it doesn't work. I think I need to have the brackets in here, because normally, if we would follow proper Lua syntax, everything would have a bracket. I don't know why I don't get syntax highlighting for Lua inside of VS Code, though. But in the end, this is how the code would look. Where is my Lua? Why the hell are you not doing it? Okay, I don't want to fiddle too much with Visual Studio Code. We could also just edit it in inside of here. It looks nicer here. However, now you can see that I have a bit of demo cube in here. The console says I'm generating a demo cube. And if I take a look now, you can actually see that we have the democube.obj and we have the democube.mtl. And if I go into my 3D viewer, we should hopefully be able to view it. So if I say open and I select my demo cube, you can see that we are getting the demo cube. And we are getting the demo cube because we generated it with Lua. But where's my Lua file? Of course, it's somewhere now. Here's my script.lua. Of course, you can see that the Lua file is not really doing something. It's more or less just calling a democube function, and it saves it under the name democube. But you can already see how this is going to get together and how the interface is going to work. We're going to have this Lua state. Later on, we're going to have a proper like representation of our 3D model inside this data struct. And we're going to have a lot of support code that helps us generating things into the data struct. And then we're going to have functions that are kind of like allowing us to select objects and groups and have a cursor somewhere, and allows us to kind of like alter a 3D model so that it kind of like being displayed in a 3D space and generated via the Lua code. So in the end, it should be just possible to write a bit of Lua code to generate every imaginable 3D model. Of course, I'm gonna aim for simple ones and like more technical stuff. Like for example, I'm a big Mirror's Edge fan, and I think that for a game like Mirror's Edge, this works because, well, I happen to have it as a background on my desktop. You can see that it kind of like models the city, and the city, since it's like a very, let's not say cubic, but you can see it's like very easily to procedure generate. You can see like the patterns. It's a bit hard now. Maybe I can do the snipping tool so they can take a look at this a bit easier. For example, if I take this building in Mirror's Edge and open this up, you can kind of like, nope, I don't want, I just want to scroll. You can kind of like see that it's kind of repetitive. And I want to be able to define buildings like that by basically having like a kit. I want to write myself certain Lua functions that allow me to kind of like generate a building with just a few commands that is kind of like telling the engine how the kind of like the base layout of the building, or the 3D modeling engine tells it kind of like what the base layout of the building is, kind of like how it's built up, and then how many stories and how high these should be, and then maybe some window generators and stuff that can help you generate some windows internally, or I want to have a different generator that can just kind of like generate the windows. And I kind of like want to build myself a tool that helps me as an engineer getting buildings like that fast. And if I happen to have something like this, we might also gonna get another more game engine related video series. If I have something that I can easily generate 3D models and enjoy it, yeah, I might do something again. But you kind of like get the idea, right? I want to have like such a procedural system. In the end, I might be completely, I thought about this, doing an API for that, like a public API, like a DLL that you can load. And maybe I'm going to get into a bit of Unreal Engine programming, and maybe this is all something that I'm just thinking about that might not even come to place. But I would kind of be interested in taking, if my 3D modeling tool is at the point where it's usable, maybe also take it and add AI integration so that ChatGPT can write the code for the tool, or also adding like an integration into like Unreal Engine, or even like an own small rendering system or something like that. Maybe continue on the real-time rendering with this video series. It would kind of like be cool to have like AI generate these stuff, right? You can write yourself like a Lua file, define your own functions, tell ChatGPT about the functions that you have defined, and tell ChatGPT that it shall generate a city layout using your like city functions that you have built for city building, and then see what you're gonna get for a city layout. And if this is feasible and really interesting to do, it would be kind of like fun to build a bit of levels with that. Just have like a ChatGPT generate a set of buildings and then placing them around, or let these even be placed by ChatGPT and tell it, hey, be inspired by games like Mirror's Edge. And I would be really looking forward into seeing how far things like that could go. But again, I'm talking about very, very far away stuff. However, I'm just working on this like 3 hours, and we already are quite far. I mean, it isn't much, but a cube completely in 3 hours with Lua and OBJ files and materials. I don't think it's too bad actually for what we got. 3 hours and this. I think it's fine. I definitely think that the pace of this video series, the way we write code is easy. And now from now on, we can write a lot of generators. I mean, like simple shapes are easy, but modifying of these shapes is going to be a pain. So what I want to do have in the end is I want to kind of like mimic how applications like Fusion and Inventor work, that you can kind of like have a procedural way that you kind of like have a starting point, and then you have certain kind of like transforms to get the 3D object how you want to have it looking like. I'm not sure how I want to do that. I kind of like think about having multiple views. You're kind of like starting with a cube. You kind of like have a cube view, and then you are kind of like, depending on what you are doing, you're kind of like getting farther and farther away with the cube by kind of like moving away from the cube view. So this is something that I might think about, but the question is if it's easy enough to have it. And at the end, we might have like similar to like how 3D modeling works, like faces and edges views, so that you can kind of like modify edges and faces. However, I need to have an interface to easily interact with these through Lua. So I kind of like think that's a good way to kind of like have like an interface that goes like from the cube down, 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 and down, so that you can always like navigate. If you know you started with a cube, you modified one face, it should be easy to go to the other side of the cube. So kind of like reselecting the object, selecting a different size of the cube, and then say like something like subdivide, and then you say something like inner, then you are at the inner one, and then you say like extrude or something. And then you have kind of like an extrusion, and the extrusion is then going to be a plane view that you can later on, of course, modify as well, or it's going to be another cube. I don't know how in the end I want to more make this, but I kind of like want to have this in a procedural way so that you can apply stuff. And if you're later on like selecting a higher level face and you're doing something like smooth, it affects all kind of like everything like downstream. If you have like a side, a cube exists out of multiple like planes. So we have a cube view that exists out of plane views. And if you have like this plane or face, I don't know how I want to implement this then, or quad, and you're kind of like something that's kind of like building on top of this quad, and you call smooth on the quad, everything that's on the quad is smoothed. Kind of like this is the way that I want to do it. So if you would kind of like extend something here and you smooth it, you kind of like get a smoothed extended version of it, and you kind of like have like this interface so that you can navigate around and smooth like the groups and stuff. I don't know if I'm capable of implementing these from the algorithmic standpoint, because I haven't too much done research in how 3D modeling applications and all the algorithms behind them work, but in the end I think we're gonna find a way to do this stuff. Okay, so now I've talking again 5 minutes. Why am I doing this always? But yeah, thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.